Before going to topic, I just want to say something about me. My name is KIRAN, and I'm selected for Anglo for September batch. So, so talking about the Dreamers package. So come on, let's learn Dreamers package with me. तो मैं थोड़ा ये बताना चाहता हूँ कि कोई सी भी पढ़ाई करने के पहले अपने को अपने बेसिक्स क्लियर करने बहुत इंपॉर्टेंट है. सो तो आज का जो सेशन है वो पूरा बेसिक के अराउंड घूमेगा. जो जो टॉपिक इंपॉर्टेंट है बेसिक के लिए वो सब आज कवर होंगे. बस तो अपन आज हाइड्रोलिक का बेसिक शुरू करेंगे. इससे पहले कुछ इंपॉर्टेंट टर्म्स है जैसे कि वर्क वर्क पावर एनर्जी. Okay, we will wait for 2 minutes. At around 8, we will start. So some guys are also coming. Wait for it. Okay, so we will start. तो मैं जस्ट बताना चाहता हूँ कि ये कोई सेशन नहीं है, ये जस्ट डिस्कशन है हम सबके बीच में. जो भी कोई सा भी टॉपिक रहेगा तो हम डिस्कस करेंगे इधर, क्योंकि ऐसे कुछ क्वेश्चंस होते हैं, ऐसे कुछ टर्म्स होते हैं जो कि हम अकेले पढ़ेंगे तो नहीं सीखेंगे. हम सबके एक्सपीरियंस से कुछ सीखेंगे तो अच्छा ही सीखेंगे. So we will start about the work, power and energy. So anyone जिसको भी पता है वर्क पावर एनर्जी का मेन डिफरेंस क्या है वो बता सकता है. एनीवन? हेलो.
I want to tell about work.
ओके ओके, गो अहेड.
Actually, whenever a force is applied on a body and a body moves in a direction towards the force applied, then the work is said to be done. Work is equals to force into displacement, and the unit of work is joules, and in CGS it's ergs, and 1 calorie equal to 4.184 joules. Am I right?
करेक्ट 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 करेक्ट.
And
एंड
when we talk about
अबाउट
power,
एनर्जी.
energy, it is a capacity or
ओके,
ability to do work.
ग्रेट ग्रेट. एसआई एंड सीजीएस यूनिट.
CGS unit is ergs and SI unit is joules, and 1 joules is equal to 10 to the power 7 ergs.
ओके ओके, करेक्ट करेक्ट. एंड एनर्जी.
Energy I have told now.
सॉरी, पावर.
Uh,
पावर
Power is
पावर.
basically a rate of doing work. So work done upon time.
सो हम
So
पावर को ऐसे भी समझ सकते हैं कि सपोज अपन को ए टू बी तक कोई से भी डिस्टेंस तक जाना है. सपोज अपन को ए पॉइंट से बी पॉइंट तक जाना है तो हम दो कंडीशन इधर एक्सेप्ट कर सकते हैं कि मैं ए टू बी वॉकिंग करके जाऊंगा और ए टू बी रनिंग करके जाऊंगा. तो जब
correct.
भी मैं वॉकिंग करके जाऊंगा तो मुझे टाइम ज्यादा लगेगा क्योंकि मेरी पावर कम यूज हो रही है. और सेम जब भी मैं रनिंग करके जाऊंगा मुझे पावर ज्यादा लगेगी क्योंकि मेरा इंस्टेंटेनियसली टाइम कम लग रहा है.
Yes, yes,
तो ये भी हो गई पावर. ठीक है.
yes.
ओके. सो एनीवन समथिंग टू ऐड? हेलो. जस्ट पिक अप गाइस, इट इज नॉट द सेशन, इट्स अ डिस्कशन.
Unit of
ओपन
power
अप
is
योर
what?
माइक एंड.
Unit of power is what?
ओके ओके, करेक्ट करेक्ट. व्हाट? और अर्थ पर सेकंड, एचपी.
1 HP is equal to 746 watts. Am I right?
Right, right.
Yes.
Oh, okay. So we'll move ahead. So we'll move ahead towards the difference between mass and weight. So anyone have any idea about mass and weight? So just speak up.
Actually, mass is a scalar quantity and weight is a vector quantity. And
Correct.
mass never changes and weight changes because it's like a force gravity acting on it. Mass we denote by kg and weight we denote by kgf or newtons.
Okay. Anyone?
Mass is the amount of matter present in the object, and weight we can say when mass is influenced by gravity, then it is called weight. Mass only has
So what is
magnitude.
your okay? So what is your weight?
So mass multiplied by gravity is weight.
Correct. So just say that suppose if we are in a space, so we are weightless because there is a zero gravity over, but we are not massless. So that means a body which always has mass and the weight factor is changed according to the gravity. Okay. Okay. So we'll move ahead talking about the distance and displacement. So basically ये सब बेसिक है, ये सब बेसिक अपन को आगे अब जैसे जैसे जाएंगे आगे आगे सेशन में सब लगने वाला है अपन को, इसलिए मैं आज ये कवर करना चाहता हूँ। क्या 10 15 20 मिनट हो जाएगा ये सब, उसके बाद अपन सीधा फ्लूइड मैकेनिक्स चालू कर देंगे। एक दो कंसेप्ट है। सो एनीवन हैव एनी आइडिया अबाउट डिस्टेंस एंड डिस्प्लेसमेंट? हेलो।
So distance.
The shortest route between 2 points is called displacement.
एनीवन?
A defined path between 2 points is called distance, and displacement states that the shortest distance between the 2 points. Am I right?
Right. Suppose we will travel from point A, talking about the distance. So let's just assume that we will move from point A to point B, that is 20 kilometer, and we will again come from B to A, that is again 20 kilometer. That 20 plus 20, that means we will travel the distance of 40. And talking about the displacement, when we move from point A to point B, that is in a any particular direction, that is denoted by positive. If we going, there is positive, and if we coming, we will negative. That means the displacement from point A to B and B to A, that is zero. Okay. Hello.
Yes.
Okay. Okay. Just move ahead. So, what is the difference between the boiling and evaporation? Just
Evaporation
anyone
takes
have any
place
idea?
in surface, and boiling
Okay.
takes place throughout the volume.
Okay. Anyone?
Boilings take place at a particular temperature, means that is
Correct.
boiling
Correct.
point. And evaporation takes
Correct.
place at any temperature. So basically, it's a
Correct.
slow process and boiling is a fast process.
Correct.
In evaporation, there will be no bubble formation, but in boiling, there will be a bubble formation.
Correct. Again. Hello. Anyone? सब बोलो रे, सब कुछ तो भी बोलो सब। एक दो ही लड़के बोलेंगे तो क्या होगा? डिस्कशन है ये, कोई सेशन वगैरह नहीं है। नहीं होगा तो नो तो बोल दो। तो मैं बता सकता हूँ ना। और so just evaporation and boiling का difference.
Hello, bro.
So just yes.
What is
Go
the
ahead.
temperature after the evaporator? Superheated or saturated liquid? मैं पूछूं?
ये पॉइंट अपन कवर करेंगे थोड़ा पेशेंस रखो। अपन अब सिर्फ बेसिक में जा रहे आज आज तो भी ये आप VCRS का पार्ट भी आएगा।
Okay, bro.
सो टॉकिंग अबाउट द इवापोरेशन एंड बॉइलिंग, सो दोनों में तो एक सेम पॉइंट है कि लिक्विड कन्वर्ट हो रहा है वेपर में। बट डिफरेंस कैसे बता सकते हैं कि बॉइलिंग में क्या होता है कि बॉइलिंग अकर्स एट एनी पर्टिकुलर टेम्परेचर, ठीक है, एंड इवापोरेशन इज ऑकर्ड एट एनी टेम्परेचर। बट द मेन पॉइंट इज इवापोरेशन कॉजेस द कूलिंग इफेक्ट। ओके, जस्ट से वो अपन हेयर कट करने के लिए बार्बर की शॉप में जाते हैं, तब वो अपने मुंह पर पानी मारता है तो कैसा ऐसे ठंडा ठंडा लगता है, क्योंकि वो ड्रॉपलेट्स है छोटे छोटे। जब भी वो अपने फेस पे जाएंगे और जल्दी से इवापोरेट हो जाएंगे, दैट मीन्स इवापोरेशन कॉजेज द कूलिंग इफेक्ट। क्योंकि कैसे होता है, जस्ट अज्यूम करो कि अपन ऊपर छत पे गए, ऊपर धूप है, समर का सिचुएशन है, अपन ऊपर गए और एक ग्लास भर पानी डाल दिया ऊपर सरफेस पे, तो क्या होगा, वो पानी इवापोरेट होना शुरू करेगा। तो इवापोरेट होने के लिए क्या करेगा, वो उसके बाजू के एरिया में से सब एनर्जी इकट्ठा करेगा और उसके बाद इवापोरेट होगा। तो जिसने भी साइड की एनर्जी ली, तो क्या होगा, साइड की एनर्जी का लॉस होगा कुछ तो भी, ठीक है। तो उससे क्या होगा, एनर्जी का लॉस होगा, उसकी वजह से क्या होगा, एनर्जी का लॉस इज इक्वल टू टेम्परेचर का लॉस। तो टेम्परेचर का लॉस जो हुआ उसमें से अपने को कूलिंग इफेक्ट मिलेगा। ये भी एक पॉइंट ऐड कर सकते हैं कि इवापोरेशन कॉजेस द कूलिंग इफेक्ट। एम आई राइट?
Absolutely right.
ठीक ठीक है, चलो तो अब चलेंगे आगे। तो रोल ऑफ बॉइलिंग ऑन प्रेशर, तो ये बहुत इंपॉर्टेंट कंसेप्ट है। ये अपन को आगे बहुत 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 जगह लगने वाला है, VCRS सब जगह। तो कुछ बता सकता है कोई इसमें से क्या होता है बॉइलिंग?
प्रेशर रिड्यूस करने से द boiling takes place at a lower temperature, and if we increase the pressure, then boiling will take place at higher pressure. Like for example, in a pressure cooker, so in pressure cooker we increase the pressure, that is why the boiling takes place at a higher temperature.
Basically,
Okay.
pressure is directly
So मेरा
proportional to boiling point.
ओके, सो मेरा क्रॉस क्वेश्चन आपसे ये है कि अगर मैंने प्रेशर कुकर लिया, सी लेवल पे प्रेशर कुकर लेके मैंने उसको उसमें आलू डाल के कुक किया, और सेम प्रेशर कुकर में माउंटेन पे लेके चला गया और उधर वो आलू कुक किए, तो दोनों में से किधर जल्दी कुक होगा?
दोनों पे सेम जगह सेम टाइम पे
प्रेशर
कुक
कुकर है तो सेम लगेगा, बट अगर ओपन है तो फिर
सेम
ब्लेंड जल्दी हो जाएगा।
करेक्ट, क्योंकि उधर वॉल्यूम कांस्टेंट है। हाँ, जिससे उधर वॉल्यूम कांस्टेंट है। ओके
ओके
ओके, सो तो देखो बेसिक तो कवर हो गए, तो वी विल जस्ट मूव एट दैट मेन पार्ट, दैट इज द hydraulics or fluid dynamics. Okay, so what do you understand by fluid? Anyone
Basically,
know about the fluid?
anything which flow because of their weak intermolecular forces is called fluid. It can
Correct.
be liquid, it can be
Fluid.
gaseous, anything.
Fluid displaces continuously due to weak shear stress.
Correct. So we will start some basic terms about that fluid that may be important for upcoming topics like viscosity, types of viscosity, different types of flows, and much more. Okay, so अब आगे का जो भी होगा हम उसको क्या करेंगे, शिप पर जो भी चीजें हैं उससे कोरिलेट करते हो जाएंगे, क्योंकि वो समझने के लिए भी आसान होगा, फर्दर स्टडीज के लिए भी आसान होगा, सबके लिए आसान होगा। मतलब जो भी हम बात करेंगे इधर, तो शिप में क्या होता है, उस पर्टिकुलर चीज का यूज कैसे होता है, उसके ऊपर बात करेंगे, ठीक है। तो वी विल मूव अबाउट द विस्कोसिटी। एनीवन have any idea about viscosity, kinematic viscosity, dynamic viscosity? Please move ahead, take initiative, try to speak, improve your communication skill.
I will talk about viscosity.
Okay,
It's basically the property of a fluid which offers resistance between movement of one layer over another adjacent layer. So whenever a fluid flows, it drags the other layer of the fluid, and that's how it's the fluid flowed. Like in case of honey and in case of water, when we flow honey on the floor and when we flow water on the floor, so water will move faster as compared to honey because the resistance that is offering in honey to one layer between another layer it's more than that water. So that's why viscosity is less in water as compared to honey.
Talking about kinematic viscosity, it is the ratio of dynamic viscosity divided by density. And its CGS unit is Stokes, and its SI unit is meter square per second.
No. SI unit is Stokes, CGS is centi Stokes.
20 Stokes. And 1 Stoke is equal to?
100 centi Stokes.
Correct. Correct. Centi means 100. Huh? Always remember the centi means 100. And
So
simple unit is meter square per second.
yes, one doubt, Kiran. If
Yes.
interviewer will ask that, tell me the unit of dynamic viscosity. So what should I have to tell? That Stokes
Just
or
say
meter?
centi Stoke. Just say centi Stoke.
Okay.
Centi Stoke. Because in ship we just कैलकुलेट ऐसे करते हैं कि 380 CST at 50 डिग्री सेल्सियस क्योंकि वो
Yes.
फ्यूल ऑयल हो गया फ्यूल हो गया उसकी विस्कोसिटी हम शिप पे सेंटिस्टोक यूज करते हैं तो देखो इंटरव्यू कैसे टैकल करना है कि उसको क्रॉस क्वेश्चन करने के लिए देना ही नहीं आप उससे बोलोगे कि सर मैं एसआई यूनिट बताओ या सीजीएस यूनिट बताओ तो क्या बोलेगा एसआई बता फिर सीजीएस बता फिर एसआई टू सीजीएस का कन्वर्जन पूछेगा फिर सीजीएस टू एसआई कन्वर्जन पूछेगा सेंटी पूछेगा स्टोक्स पूछेगा इतना क्यों जस्ट से सिंपल सेंटी स्टोक बात खत्म उधर ही अगर
So,
उसने आगे पूछा तो बताने का
so when comes the rules of meter square per second?
इट्स अ सिंपल यूनिट नॉट मोर
Okay,
देन
okay. Okay,
Bro,
got it.
bro, in Google it is showing that CGS unit of kinematic viscosity is Stokes.
सेंटी
But
स्टोक्स
It's wrong. It's wrong.
okay, bro.
एसआई यूनिट इज स्टोक्स एंड सीजी यूनिट इज सेंटी स्टोक्स
Yeah, but I
ओके
searched in Google, but it is showing universally.
सो डायनामिक विस्कोसिटी कौन कोई बता सकता है
It's basically fluid resistance to flow or tangential force per unit area required to flow from one place to another.
करेक्ट
And its unit is Newton second per meter square. That is Pascal second.
करेक्ट
It can also be
CGS
defined
unit
as
What?
CGS unit is
CGS unit of?
dynamic viscosity
Uh,
It is poise, right?
poise right
okay.
right and what is 1 Newton second per meter square is equal to how many poise
10 poise.
10 points.
correct and 1 poise is equals to how many Newton second per meter square
10 power minus
देखो
1.
ऐसे क्वेश्चन करेक्ट देखो ऐसे क्वेश्चन होते हैं क्या ये इंटरव्यू तो नहीं पूछेगा पर ऐसे क्वेश्चन है क्या कोई से भी रिटर्न एग्जाम में जो भी ऑनलाइन एग्जाम आप सेंटर पे जाके देते हो अगर देते हो तो इसमें डेफिनेटली क्वेश्चन पूछते हैं ऐसे तो अगर ये आपके बेसिक्स क्लियर हो गए तो आप उधर क्लियर करेंगे फिर आगे इंटरव्यू में जाओगे ठीक है और ऐसा भी डायनामिक विस्कोसिटी को और एक नाम है एब्सोल्यूट विस्कोसिटी तो ये भी ध्यान में रखो छोटे छोटे पॉइंट्स एक एक मार्क के लिए होते तो एक छोटे छोटे पॉइंट पे आप थोड़ा ध्यान दोगे तो अच्छा होगा ठीक है so we'll move ahead so what is the relationship between viscosity and the temperature that's important point एक्चुअल शिप में बहुत यूज होता है
When we increase the temperature, the viscosity will decrease.
करेक्ट एनी एग्जांपल
We can take the example of the fuel oil which we used on ship from 50 degree to 130 degree. So the CST will move from 380 to 13 CST.
करेक्ट जो सिंपल एग्जांपल और है कि जब देखो अपन जब कुकिंग को ऑयल यूज करते हैं कोई सी चीज फ्राई करने से पहले आप वो ऑयल देखो उसकी विस्कोसिटी देखो और जब वो हीट होता है तब उसकी विस्कोसिटी देखो, आपको उधर ही पता चल जाएगा कि विस्कोसिटी और टेम्परेचर का एक रिलेशन है। जब भी टेम्परेचर बढ़ता है विस्कोसिटी इवेंचुअली कम ही होती है। ठीक है,
One more example I want to add, that is bitumen that we use on road.
बीट में, हाँ, यस यस।
Yes,
Bro,
another
one more thing.
example that honey is thicker first, and by adding heat, it goes to thinner.
ओके ओके ओके, करेक्ट करेक्ट।
Bro, in case of gases, it is
सो
directly.
देखो,
In case of gases, it is
हेलो,
direct. Bro,
योर वॉइस इज नॉट क्लियर।
in case of gases, when temperature increases, viscosity also increases, no, bro.
केस ऑफ
And
गैसेस ओनली।
He
yes,
wants
sorry.
to know what will happen if we increase the temperature of a gas. Like in case of liquid, when we are increasing the temperature, the viscosity is reduces, means the flow will be easier. So what will happen when we increase the temperature of a gas? Because gas is also a fluid.
तो इट इज बिकॉज ऑफ इट्स इंटरमोलिकुलर फोर्स। सो देखो, जब भी अपन गैस को हीट करेंगे तो क्या होगा, उसके मॉलिक्यूल्स ने क्या, वो पास पास आके चिपकने लगेंगे। तो जब भी वो पास आएंगे तो उसकी विस्कोसिटी भी बढ़ेगी। ठीक है, तो देखो, एक गैस है, इतने वॉल्यूम में समाया है, जब भी मैं उसको हीट करूंगा तो इतना हो जाएगा, और हीट करूंगा वो इतना हो जाएगा, उसका इंटरमोलिकुलर फोर्स कम 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 होते जाएगा। ठीक है, उससे उसकी विस्कोसिटी बढ़ जाएगी इन केस ऑफ गैसेस ओनली। ठीक है,
गैस में हीट करने से वो वॉल्यूम डिक्रीज होगा?
Volume will increase, right? When we heat the gas.
Yes,
The
yes.
molecule collision will increase. To
Actually, the
collision, the
internal energy will increase so that
yes,
the viscosity will decrease or increase.
हेलो।
listen. In case of solid, what happens when we increase temperature? The intermolecular force between molecules become weaker. So in case of solid, on increasing temperature,
Your voice is
viscosity
not clear,
decreases.
your voice is not clear। ओके ओके, नेटवर्क इशू, नो प्रॉब्लम नो प्रॉब्लम। ओके, एनीवन, किसी को भी कुछ ऐड करना है तो वो ऐड कर सकता है, नहीं तो अपन आगे जाएंगे, विस्कोसिटी इंडेक्स के बारे में देखेंगे। विस्कोसिटी इंडेक्स क्या होता है, कैसे होता है। ठीक है, सो विस्कोसिटी इंडेक्स दो टाइप के होते हैं, एक हायर विस्कोसिटी इंडेक्स, दूसरा लोअर विस्कोसिटी इंडेक्स। तो कोई बता सकता है हायर विस्कोसिटी इंडेक्स, लोअर विस्कोसिटी इंडेक्स क्या होता है?
Actually, in lower viscosity index, as soon as we increase the temperature, the viscosity changes will be more. And if the higher viscosity index is there, so when we will increase the temperature, the viscosity affected will be less.
एंड हायर विस्कोसिटी इंडेक्स?
Less viscosity. In higher viscosity index, the less viscosity is affected with the change in temperature.
Actually, less viscosity will be affected with change in temperature in higher viscosity index. It is basically a written measure of change in viscosity with change in temperature.
करेक्ट। तो जैसा देखो, शिप पे क्या होता है, जो भी हमारा फ्यूल होता है, फ्यूल जो भी इंजन सिलेंडर के जो भी सिलेंडर है उसके अंदर हम जो छोड़ते हैं, उसकी विस्कोसिटी वो हमेशा लोअर होनी चाहिए, लोअर विस्कोसिटी इंडेक्स होनी चाहिए उसकी। तो देखो, लोअर विस्कोसिटी मीन्स हाइयर विस्कोसिटी अफेक्टेड विद रिस्पेक्ट टू टेम्परेचर। तो जब भी हम बंकरिंग के टाइम फ्यूल को लाते हैं फ्यूल टैंक में, तो उससे क्या होता है, तो उसका टेम्परेचर होता है 50 डिग्री, सपोज 50 डिग्री सेल्सियस, और उसकी विस्कोसिटी होती है 380। तो देखो, अगर हम उतना विस्कस फ्लूइड, वो जो नोजल है नोजल, तो उससे स्प्रे करेंगे तो स्प्रे ही नहीं होगा, तो उसको उसको अपने को हीट करना होता है। वो हीटिंग का प्रोसेस है अलग, वो अपन कभी और डिस्कस करेंगे। तो उसको हीट करना होता है क्योंकि वो चोक नहीं हो जाए नोजल में। तो उसके लिए उसकी प्रॉपर्टी होनी चाहिए कि लोअर विस्कोसिटी इंडेक्स। और टॉकिंग अबाउट द हायर विस्कोसिटी इंडेक्स, हायर विस्कोसिटी इंडेक्स होनी चाहिए ल्यूब ऑयल की। ठीक है, हायर विस्कोसिटी इंडेक्स में लोअर विस्कोसिटी अफेक्टेड विद रिस्पेक्ट टू टेम्परेचर। तो देखो कैसे होता है, दो मेटिंग पार्ट, दो कोई से भी रिलेटिव मोशन पार्ट है, तो हम उसके ऊपर जब भी ऑयल अप्लाई करेंगे, तो जब भी वो रिलेटिव मोशन करेंगे उसके बीच में हीट होगी। तो हीट से क्या होगा, तो ऑयल बर्न होगा ज्यादा। ठीक है, तो उसकी विस्कोसिटी ज्यादा चेंज नहीं होनी चाहिए, विस्कोसिटी उतनी होनी चाहिए, कम होनी चाहिए उसकी विस्कोसिटी एज कंपेयर टू दैट फ्यूल। मतलब जो भी हम शिप पर फ्यूल यूज करते हो वो लोअर विस्कोसिटी इंडेक्स का होना चाहिए, और जो भी ऑयल यूज करते हो वो हायर विस्कोसिटी इंडेक्स का यूज होता है। ठीक है, हेलो। So just move it about different types of flows. So just guys pick up,
Steady
जब
and
भी आप ओके, सो जब भी आप कुछ बोलो तो हो सके तो कैमरा ऑन कर दीजिए, हो सके तो। ठीक है, तो टाइप्स ऑफ फ्लोज कोई से भी, कोई भी आप बता सकता है तो बता दो। स्टेडी फ्लो, अनस्टेडी
No,
फ्लो क्या
can you
होते हैं?
speak in English? We can't understand. I can't understand.
ओके ओके ओके, so my English is not very good, so for that reason I am talking in Hindi. So we'll try. Okay, no problem. So what is the steady flow and unsteady flow?
Means the amount of flow flowing per second will be constant. And in unsteady flow, the amount of fluid flowing, liquid particles per second is not constant.
Correct. Even
There are two types of flow, laminar flow and turbulent flow. The laminar flow is Reynolds number below 1600 is laminar flow, above is 2600 is turbulent flow. The laminar flow also called as a steady flow, turbulent flow called as a unsteady flow. Am I right?
I
No, I
think
think
you
the
are
Reynolds
not
number
right
will
over.
be less
less
than
than
2000.
2300 is laminar flow and greater than 4000 is turbulent flow.
When the fluid is moving in a very well-defined streamline path, then it is called laminar flow. And in case of turbulent flow, the fluid moves in a zigzag manner.
तो
Actually, in
लैमिनर फ्लो
turbulent
क्या होता है, कोई भी एक्सप्लेन करो। टर्बुलेंट वो छोड़ दो, वो क्या रेनॉल्ड्स नंबर, वो क्या कैसे कैसे, पर लैमिनर फ्लो होता क्या है? रेनॉल्ड्स नंबर का छोड़ दो, होता क्या है ये बताओ।
Actually, a flow in which liquid particles follows a definite path, and the path of the liquid particles have a same velocity at one point, and the liquid
करेक्ट,
particle does not cross each other path. That is called laminar flow. But when in case of turbulent flow, the liquid particles cross each other path. They do not have any definite path. They do not have any same velocity at one point.
करेक्ट, दैट इज द डिफरेंस, major difference between the laminar flow and turbulent flow. Okay, so these flows are very important among the all types of flow. Also there are various types of flow like uniform, non-uniform, rotational, irrotational, compressible, incompressible. Okay,
Talking about compressible flow, if the density of the fluid remains constant throughout the flow, then it is called compressible flow. If the density varies, then it is called incompressible flow.
irrotational, rotational flow. Hello.
If the fluid while flowing along its streamline rotates about one axis, then it is rotational flow. And in irrotational flow, they do not move along an axis, about an axis.
Own axis.
Of rotation.
Yes. So anyone have to add something? Just move ahead. Hello.
The previous point where the compressible and incompressible flow, one guy explained. So in that, he said incompressible flow density changes, right? Sorry,
Yes.
constant. It's constant. He said constant. That is not right.
And density changes in compressible flow
Okay.
from point to point. So density changes from point to point. That is a basically compressible flow, and density does not changes from point to point or any point. That is the incompressible flow. That means, okay. So we will move ahead. So in the interesting concept of that critical velocity. Also, we'll cover about the Reynolds number over there. So anyone have any idea about critical velocity?
Velocity at which
Let's
the flow of liquid changes from laminar to turbulent. So it is denoted as critical velocity.
okay.
And there are two critical velocities: upper critical velocity and lower critical velocity. Upper critical
Okay.
velocity is when the transition flow changes to turbulent flow, and from lower critical velocity is when it changes from laminar to transition flow.
Okay. So what is the Reynolds number?
Reynolds number is the ratio of inertia force by viscous force, and its formula is rho Vd by mu.
The inertia force to the viscous force per unit area of the flowing fluid.
Okay,
Per
bro.
unit area. Okay.
Okay, bro.
Okay. So what is the flow rate?
Amount of fluid flowing per unit time, meter cube per second.
So on ship, why we require the flow rate? Anyone have any idea about that?
To calculate how much fuel we have consumed that from point A to point B, if we are traveling, we have to know at how much fuel we are using. If we don't have that calculation, so that will be related to money. So that we are using flow rate and all.
So. Anyone have add something? Just move ahead.
Other point is, if we want to do lubrication, then we need to have certain amount of flow rate. So in that case, we can monitor the flow rate to know if we are like supplying enough quantity or
Lube
not.
oil is consuming. Okay, correct. So we'll move ahead and talking about the nozzles. Okay. So what is nozzle or types of
Nozzle,
nozzle?
nozzle is used to control the direction or the or to increase the velocity of the fluid or liquid.
Decrease the velocity. Okay.
There are
There are
three
two
types
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 of
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 nozzle.
nozzle.
three types of
Convergent
nozzle.
nozzle, oh, convergent, divergent nozzle. I know.
And throat.
Okay. Convergent, divergent, or convergent divergent nozzle. Okay. So basically, convergent divergent is the just adding that convergent nozzle and up next up to divergent nozzle. So basically it forms a choke section over there, choke section or throat section over there. So basically it is used for converting the subsonic velocity directly into the supersonic velocity. Okay. So
Didn't
what
get what
happened
are
in the
didn't get what are the
so
types
basically
of this
okay
nozzle.
okay okay. So basically there are three types of nozzle over there. First one is the convergent nozzle, second one is divergent nozzle, and third one is a convergent divergent nozzle. So this nozzle So convergent divergent nozzle is made in a such way that first we add that convergent nozzle next up to the divergent nozzle. That means first one is the convergent nozzle and second one is the divergent nozzle. So when we see that convergent nozzle, its area is reduces gradually. So and after we adding that divergent nozzle over there, that means the area is increasing gradually. That means at that point the throat section or the choke section is created over there. That means at the middle, at the middle there is a very small area over there. Okay. Basically, this is the convergent divergent nozzle.
Okay, how subsonic is converted into supersonic? That's the
Okay. So basically, so subsonic, supersonic, hypersonic, these are the basics of that Mach number. Okay. So if Mach number is less than 1, then this velocity is known as the subsonic velocity. So basically, this subsonic, sonic, hypersonic, supersonic velocity is depends on that Mach number. And Mach number is the ratio of that velocity of the fluid to the velocity of sound. That means we will compare that velocity to the sound velocity. So suppose if our Mach number is 1, at that point the velocity is subsonic velocity. And if the Mach number is 1, that means the sonic velocity. And if the Mach number is more than 1, it's a supersonic. And if the Mach number is more than 5, that means it is the hypersonic. So basically we will know that the hypersonic velocity for that jet we will see that jet going with a high speed. That is the velocity of that. That means the jet is moving to the more than speed of sound. That is called as the hypersonic velocity. Okay.
okay. Where it is applicable to ship in
Ship.
subsonic.
So basically, see, so it is used in a freshwater generator. The device known as ejector over there, ejector. So at that point, at that throat section, what happened over there? The velocity is maximum. Okay. So because of the restricted area, the velocity is maximum, and at that point, pressure is minimum. And if you know that, we will discuss that concept of that pressure and that boiling point. So at that when the pressure is minimum, at that point boiling point is also reduces. That means when pressure decreases, boiling point decreases. That means when we take the seawater from the pump and at that point or the choke section, the pressure is reduced. That means boiling point is reduces, and for that boiling we just uses the engine jacket water over there. And after that boiling at a lower temperature, that means we know that the water boils at 100 degrees Celsius at 1 bar, but water boils at 40 degrees Celsius at 2 bar, 3 bar, 4 bar. I don't know that specific number of that boiling corresponding to the pressure. But if the pressure is reduces, boiling point is reduces. Because of that, we can boil the seawater at very low boiling point, below that 100 degrees Celsius. So our money behind that burning of fuel is also reduces. At that point, the convergent divergent nozzle is used over there, and that particular nozzle used in a freshwater generator causes ejector. Okay.
Okay, I got it.
Get it? Got it? Okay, we'll move ahead. We'll move ahead about the देखो अब आ गए continuity equation बर्नौली से तो सबको पता होगा just revise करते. So continuity equation, anyone have any idea about that? Just say, speak up, try to speak up.
Talking about kinetic equation, the rate at which the mass of the fluid entering the system is equal to the rate at which the mass of the fluid leaving the system. Simply, we can say that area into velocity at the inlet will be equal to the area into velocity at the outlet.
Fluid enter in the pipe, which is exit is equal to which is enter, which means A1 is A1 and V1, which means velocity and area is equal to velocity another pipe of area. velocity and another.
The main thing we can get from the continuity equation is when the area increases, the velocity also, like when the velocity decreases and the area decreases, the velocity increases. So that is what the continuity equation mainly talk about.
Okay, just we can say the simple in simple word, we can say mass flow rate is constant throughout the section. Okay, am I right?
Yes, bro.
Okay, so let's move ahead about that. Always remember one point. When we talk about the rate, always remember that when a word come rate, that means per unit time. Okay, just divide it by time. Always remember that. It's keyword. Okay, so Bernoulli's theorem.
The summation of pressure energy, potential energy, and kinetic energy remains constant throughout the flow or pipe.
Okay, okay. Anyone?
So it is a Bernoulli's theorem relates the like thing between pressure, velocity, and the like elevation of moving fluid. So it works on the conversion of energy.
Anyone? तो देखो एक सिंपल एग्जांपल और एक जस्ट नंबर से समझते बर्नौलीज थ्योरम क्या होता है कैसे होता है सपोज देखो at a particular point A to B at A the summation of pressure energy potential energy kinetic energy is always equal to summation of pressure energy potential energy kinetic energy at outlet suppose at inlet the pressure energy summation of that is 10 and आउटलेट इज ऑल्सो 10 सपोज देखो अगर किसी पॉइंट पे प्रेशर एनर्जी बढ़ गई तो आगे जाके वो कम हो जाएगी और कभी काइनेटिक एनर्जी बढ़ गई तो प्रेशर एनर्जी कम हो जाएगी ये सेम कंसेप्ट यूज होता है दिस सेम कंसेप्ट इज यूज्ड इन सेंट्रीफ्यूगल पंप that we will be discuss in tomorrow's topic how the Bernoulli's theorem is actually applied in that centrifugal pump. And that's a key question or major question that will be asked during the interview of any college. Explain the centrifugal pump and how Bernoulli's theorem is act over there. That means on which principle centrifugal pump is act over there. Okay. Bernoulli's theorem. So what is the Venturi effect?
It is the decrease in pressure at the throat due to increase in the velocity of the fluid due to the convergent section. And then after that it is followed by a divergent section where its pressure is again normal.
Same concept. We will discuss like that convergent divergent nozzle that is called as the eductor. So just spelling of that eductor is ejector. So ejector is used in that freshwater generator over there, as I already say that. So basically, what happened over there? So when we passes any kind of fluid to a choke section or a throat section, that causes which increases in a velocity and decreases in a pressure. Because of that, pressure is always directly inversely proportional to that velocity. That means when the velocity increases, pressure decreases, and when pressure increases, velocity decreases. Okay, so we will move ahead about that Pascal's law.
When pressure is applied to one section of an incompressible fluid, then it is equally transmitted in all the directions. An example of
Correct.
Pascal's law can be a hydraulic jack.
Correct. Anyone?
Pressure applied on an enclosed fluid is distributed equally on every point of the fluid and also on the wall of the container.
Correct. So we will just move ahead. Triangle next, like cohesive force, adhesive force, surface tension, and capillarity. So just going one by one. What is a cohesive force?
Intermolecular forces of same substances is called the cohesive force. So example, mercury, chewing gum.
Correct.
And adhesive force, the
And
intermolecular forces between two different substances.
okay. So just
Here,
about the
intermolecular force or intermolecular force of attraction.
okay. So the major role played by mercury in cohesive and adhesive forces, like mercury has a very small adhesive force with the most container material and a strong cohesive force. Okay. So because of that, mercury has a higher cohesive force. So we'll move about the surface tension. That's very interesting topic. Surface tension. Anyone have any idea about that surface tension? Just move ahead.
In water, there is no upper in molecules, so there is no interaction
Brother,
intermolecular
your
force.
your voice your voice is not clear.
Tendency of the fluid surface to string its minimum surface area is called surface tension.
Correct. So how the surface tension is created? Do you know?
It is due to the cohesive forces.
The cohesive force which
Or
are acting downwards, the water layer is stronger than the adhesive force which are acting upwards. So due to which, because of this thing, the tension is created in the surface of the water.
okay. So always remember that it's not a property of fluid. It's a property of fluid surface. Okay. So it's a property of fluid surface which will be tried to be in a minimum surface area. It's a property of surface. Okay. So because of that higher surface tension, so because of surface tension, the mosquito will be float on that water over there. So basically on that surface there is a conflict between cohesive and adhesive forces between that water molecule. So because of that conflict is created over there on that layer over there, and that phenomenon is called as that surface tension. Okay, that means in simple way we can say that लिक्विड सरफेस की प्रॉपर्टी हमेशा सिकुड़ होती है, सिकुड़ने की कोशिश, ट्राई टू बी श्रिंक, कभी भी वो श्रिंक करता है सरफेस. ओके. So what is meant by capillarity?
See, it is the ability of the fluid to rise against the action of gravity in a narrow tube. And it is caused because adhesive force is greater than the cohesive force of the fluid.
Okay. Anyone? Anyone else?
Is the rise or fall of a liquid column in a small tube relative to that of the liquid in which it is dipped.
So any example of that capillarity?
Mercury, so it
Barometer.
will.
If you take barometer, that is the best example of capillarity. So if
Example?
barometer,
So in comment section.
In case of lamp,
Yes,
throw to the,
correct.
throw to the oil rises.
Correct. So just say that if we have a container which is filled with that water and we will just put that water glass tube over there. So what happened over there? Anyone have any idea? That will be rise or fall. And if rise, then why rise? And if fall, then why fall?
Can you repeat the question?
So suppose if we have a container which is filled with the water and we just dip that glass glass tube in between that. So what happened to the glass tube? What the water is go upside or water will go downside?
It will go up.
If the adhesive force is greater, then adhesive force of the fluid on the glass tube is greater, it will go up.
It is also depends on the area. Higher the area, lower the capillary length. So lower the area, higher the capillary length. So it also depends upon the area.
Area. And what about the mercury?
It will go down because their cohesive force is more.
Cohesive force is more than the adhesive force. Correct. So what is remaining over? Okay. So the main concept and the interesting topic which will be asked always in interview, like what is Archimedes principle? Much more questions on that, like why ship float on water and why any kind of hard weight is sink inside the water. So anyone have any idea? Just move ahead. Try to explain.
When a body is partially or fully immersed in a liquid, it experiences an upward thrust called buoyant force, and it is equal to the weight of the fluid displaced by the object. That is
Correct.
Archimedes.
Anyone?
And the buoyant force will be equal to the weight of the liquid displaced by the object.
Okay, so also that buoyant force is also depend on the density of that water. Suppose if you have the density of that river water is 1000 kg per meter cube, and talking about the sea water, the density of the sea water is 1025 kg per meter cube. That means the buoyant force acting on a same weight on sea is higher side as compared to the river side. Okay, am I right?
Yes, brother.
Okay. So why ship float on water?
Ship float on water. Metacentric. I didn't know about metacentric point. Do you clear that?
So why will you will go that to the metacentric point, metacentric height, metacenter? Why? What I ask about just why ship float on water. So if we mention that metacenter point in the interview, so interviewer give more about that focus on the metacenter point. So just keep it simple, short, and in easy way. Anyone? What
Because
is
of
that?
vacuum space in the inside the ship, the density of the ship is lesser than the density of the water, so it floats on the water.
Anyone?
Because ship has a large a surface area, and it displaces a large amount of
Correct, correct,
volume which
correct, correct,
rebalances.
correct, correct. So buoyant force acting on a ship is greater than its weight because it displaces larger volume of water as compared to its weight. So because of that, the ship float on water. Correct.
Repeat it once more.
What? Repeat again.
Yeah. Hello. Repeat
Hello,
it
come
once more.
again.
Yeah. Come again.
What are you saying? So come again. I don't get it.
You
Uh,
are
repeat, repeat the
I
answer
think your
once more.
network. Okay, so buoyant force acting on a ship is greater than its weight because it displaces larger volume of water as compared to its weight because of more surface area of that ship. So if the surface area of any object is more, so it displaces more amount of volume of water. Okay.
Yeah, I get it.
Get it?
Yeah, I get it.
Okay. So और एक चीज है कि कोई सी भी शिप हो उसका जो भी बेस होता है बेस वो हमेशा मतलब हॉलो रहता है हॉलो. Okay. So because of that we will increase the surface area of that ship. So basically it's the point included in the ship structure how the ship is made to calculate that buoyant force acting on that ship. So that means the bottom part of the ship is hollow. Because of that, we will generate more surface area over there. Okay.
Bro, one question. Like, what about the sometimes I think it is asked in interview that what are the assumptions in Bernoulli's principle and all that.
Assumptions in Bernoulli principle. So
Yeah.
basically, yes. Just say that if the says Bernoulli's assumptions are like the fluid which has the flowing through the pipe which will be have zero friction, frictionless flowing frictionlessly between that tube. That is the first assumption over there. I only
And then the one-dimensional flow.
know about that.
The
Only
viscosity is zero for that fluid, and the
the
flow
fluid
is
will be frictionless. Okay.
Okay.
So I think so. If anyone asks that type of question, okay, okay, no problem. So basically, today we will cover most of that basic part over there, and after that we will move ahead with the pumps in tomorrow's session. Okay. So just for 5 minutes, what are the different types of pressure gauges? If anyone have any idea, just hello.
The normal pressure gauge and vacuum gauge and compound gauge.
Anyone?
gauge pressure, vacuum pressure, and compound pressure gauge.
Then barometer.
Different types of gauges. Anyone have no? Like a
Vacuum
man.
gauge, compound gauge.
Okay.
Yeah. And
Like
the
manometers.
normal pressure. Okay, that.
Okay, manometers, mechanical gauges. Like in manometer, there's a piezometer, simple YouTube manometer, single column manometer, vertical type, horizontal type, differential YouTube manometer, inward YouTube differential manometer, and in that mechanical gauges like bird on tube, diaphragm, dead weight, bellows, etc., etc. Okay, so just move through that topic on YouTube if you have little interest with that. So we will winding up over there today's session over there. So in tomorrow's the topic, we will just move towards the pump, and that is the very important section of session for that interview and any kind of stuff. So for tomorrow's lecture, we will just focus on that pump, like what are different types of pumps, how to answer the question which will be asked by the interviewer, like what are the different, what is the centrifugal pump, explain the working, how pressure is created at the discharge of the centrifugal pump, then NPSH, then screw pump, gear pump, various types of pumps. Okay. Hello.
Yes, bro.
Okay.
Okay. So don't miss tomorrow's topic. So tomorrow's topic is very very important. If you know that, देखो कल जो भी होगा उसमें से एक तो क्वेश्चन हमें फिक्स ही रहेगा इंटरव्यू का, फिक्स ही रहेगा। एक तो वो पूछेगा सेंट्रीफ्यूगल पंप, नहीं तो वो पूछेगा गियर पंप। इस दोनों में से हम वो पूछेगा ही पूछेगा। आप अब आंसर कैसे करते हो उसको, उस पर आपका सिलेक्शन डिपेंड होता है, क्योंकि ये क्वेश्चन इंट्रोडक्शन या उसके बाद दूसरा या तीसरा क्वेश्चन यही होता है, सेंट्रीफ्यूगल पंप एक्सप्लेन करो सीधा। सो हाउ यू टैकल दैट आंसर, दैट्स देखो ये फर्स्ट क्वेश्चन होता है, अगर आपने आपने इंप्रेशन अच्छा डाला इंटरव्यूअर के ऊपर तो आपकी उधर ही चांसेस है कि आप आपका हो जाएगा। ठीक है, तो कल का टॉपिक मिस मत करो। ठीक है।
Okay, I have a doubt. I have a common doubt.
Okay.
Is engineering material is mostly asked in entrance exam or interview?
So interview and entrance exam is also asked like what what principle used in that centrifugal pump, like Bernoulli's theorem. So what are the different types of seals used in that pumps? What are the different types of pump and application on ship?
No,
तो यही बोलना चाहता हूँ कि तो यही बोलना
no, I
चाहता हूँ
am
कि
asking
देखो,
about engineering material.
what are you saying?
Engineering material I am asking about.
I don't get it.
Engineering material, bro.
What engineering?
Engineering materials are mostly
Engineering material.
is asked in interview or entrance exam. That subject.
Materials, engineering materials. So it is asked like mostly it's asked in that entrance exam. Entrance exam it will be asked, but try to prepare some 2 to 3 questions of engineering material for interview also. So go through the testimonies, collect the question, and prepare for that. Not that big deal. We will discuss in upcoming sessions. Okay.
Okay, bro.
Okay. So don't miss tomorrow's lecture. So thank you all. You can leave the meeting now.
Okay, thank you, bro.
Thank you.